Okay, so the first way that we can solve the system of equations is we can have one solution. And one solution graphically, the two lines are going to intersect at a point. In this example here, the point is 0, -2. That is the solution for the system of equations. So if I were to take these two equations and plug 0 and -2 into them, it would work in both equations. So if I went to this 2x minus y equals 2, and I plugged a 0 in for x, so I did 2 times 0 minus -2 for y, that is going to give me a true statement. 2 times 0 plus 2 equals 2. And if I go to the second equation, x plus y equals -2, and I plug 0 in for x, and I plug -2 in for y, that will also give me a true statement. So I get a true statement in both equations. The solution works. That's one solution. Two lines will intersect graphically. No solution graphically, these lines will never intersect. They're going to be parallel lines, so they're going to have no solution. So one way that you can check that with lines, graphing them, checking the slopes to see if they're parallel. If you were to take anything and plug it in, it would not be true. Notice here the 3x plus 2y on both of these, but they have different numbers after the equal sign. Okay, so if x and y are the same, it's never going to be true here. And then this last case here, this forms one line, and that's infinitely many solutions, which means anything that I plug in is going to give me a true statement. These equations are the same. This is a multiple of this equation here. If I multiply this entire equation by 2, I get the second equation here. So the equations are going to be multiples of each other. Now, graphically, this is what they look like. When I'm solving the equation algebraically for no solution, you're going to end up with a false statement. Okay, when you're doing this algebraically. So it'll look something like this. You'll get a 0 on one side and then like a 5 on the other side. Okay, 0 does not equal 5. That's false, so that's the no solution case. For infinitely many solutions, you're going to end up with a true statement. So everything is going to end up eliminating, and you're going to get something like this. 0 equals 0 or 5 equals 5. Typically, it's 0 equals 0. So before we start solving those, first thing we'll do is we're just going to check to see if we have the correct solution here. So that's one thing we'll do. So for example, 1 you have, is 1, 4 a solution to the following system of equations? You're just plugging 1 and 4 in for x and y, and it has to be true for both equations. Okay, so you're going to go x equals 1, y equals 4. So you're just plugging these values in. So in the first equation, we're going to go 3 times 1 plus 2 times 4 equals 11. So 3 times 1 is 3, 2 times 4 is 8, and 3 plus 8 equals 11. That's true. So it works in the first equation. Then we're going to go to the second equation. I have negative x, so -1 plus 4 equals 3. And that is also true. So if it works in both equations, you say yes, 1, 4 is a solution to the system of equations. So that's the first thing you're doing, is you're just checking to see if an ordered pair is a solution. Okay, so like I said, there are 3 different methods to solving a system of equations. So the first method is graphing. So graphing, you're either going to have the lines intersect, or they'll be parallel, or they'll be the same line. Then you have substitution, okay, where you're going to plug one equation into the other. Then you have elimination, where you're going to use multiplication to get a variable to eliminate. And we're going to go over all of the different methods. So let's start with graphing. So for graphing, you're just graphing both of these on the same graph and then seeing where they intersect. Okay, so if I want to graph these, I'm going to take each of these equations and I'm going to get them in y equals mx plus b form. So my first equation I have 3x plus 2y equals 11. I want to isolate the y. So I'm going to take the 3x and I'm going to subtract it over here. It's going to cancel out on the left. I'm going to bring down a 2y. I'm going to write these next to each other because they're not like terms. So I'm going to have a negative 3x plus 11. Then I'm going to divide everything by 2. Okay, it's going to cancel out on the left. I'm going to get y equals negative 3 over 2 x plus 11 over 2, which is 5.5. So it's a little tough to graph, but we should be okay here because it's just half here. So I'm going to start with my y-intercept, which is 11 over 2, so that's 5.5. So I'm going to go up to 1, 2, 3, 4, 5, and then halfway. So that's going to be right here on my graph. Then my slope is negative 3 over 2. So from this point, I'm going to go down 3, so 1. And when I go down, I have to go, since I start at 0.5, go to the middles. So 1, 2, 3, and then over 1, 2. So it looks like this next point is going to be about right here, which should be at 2 and then 2.5 for the point there. And then we want to draw a line through these points. So I don't think I can do very good lines here, but we'll try. Get it to cross through those points. And then we have our first line graphed. Let's see if I can. There we go. Okay, so we have our first line. Okay, now we're going to take our second equation, which is negative x plus y equals 3. And I'm going to bring it over here. And I want to get this one in mx plus b form. So in this one, I'm just going to add the x to both sides. Okay, the x's are going to eliminate over here on the left. And over here, I'm going to get y equals, and then I can't do 3 plus x, so that's just going to give me x plus 3. And then I'm going to go ahead and graph this equation. So I have a y-intercept of 3. So I'm going to go to 1, 2, 3, right here. And then what's my slope of this line? Just 1. Yep, in front of this x is just a 1. So my slope is going to be 1. So I'm going to go up 1 over 1. Okay, and then I have another point right there, which is actually where it ends up intersecting. So let's put this line on here. And there we go. So we have our two lines. And then what we do is we look at where they intersect. So they intersect right here. And we want to get the coordinates of that point. So what are the coordinates of that point? One on the x and on the y. I think it's 4. 4. 1, 4. Okay, notice it's actually the same set of equations that we did prior in the last example. But we can take this and we can always check it. When you're graphing, you do want to do that. Just check it to make sure that it fits. So I'm just going to go here and I'm just going to type it in my calculator real quick. 3 times 1 plus 2 times 4 gives me 11. Then negative 1 plus 4 gives me 3. So it works in both equations. So I know I graphed it correctly. Okay, so for your types of solutions, there's a certain way to write the answer. When you have one solution, you're going to write the answer as an ordered pair. So just parentheses, x comma y. When you're doing substitution and elimination, you're going to get an x value with a number, and you're going to get a y value with a number. When you get no solution, you're going to get two parallel lines. The way you are going to write that, let me check for sure. Is going to be like this. There's going to be an option that says the solution set is, and then 0 with a line through it. Okay, so 0 with a line through it, that's null. That means there's no solution. And then again, like I said, algebraically, you're going to get a false statement. So something like 0 equals 5. And then infinitely many solutions, when you graph it, it's the same line. The way you're going to write that is it's going to be in interval notation. So it's going to look like this. You're going to have your little curly bracket, or sorry, set builder notation, x and then a line. Not x and then a line, sorry, x, y, and then a line. Let me come back here. So, okay, curly bracket, parentheses, x, y, like that, then your line. And then it's just going to have the equation, the first equation in it. It's not going to have the word equation, it's going to have an actual equation in it. That is infinitely many solutions, the one that you would pick. And then algebraically, substitution or elimination, you're going to get a true statement. Everything's going to end up canceling out, and you're going to get 0 equals 0. Okay, so let's start with substitution. Now, when you're asked to solve graphically on your homework, you're going to have to actually graph the lines. But when it says substitution or elimination, you can really do whichever one you prefer. Okay, if it says to do substitution, then that means that substitution is going to be the easier method for doing that. Okay, if it says to do elimination, then elimination is going to be the easier method for doing that. So it is good to know both. Substitution. Okay, what you're doing is you're isolating one of the variables, so x or y. So let's just say here, you're substituting. So I'm saying, okay, well, x equals 11. And that means I'm going to take what x equals and I'm plugging it into the equation for x. So I'm plugging 11 right there. So I'm going to say 2 times 11 minus 6y equals 4. That will then allow me to solve for the y value. Okay, I'm not going to actually go through and do that. So what we're going to do here is we're going to go through example 3. We're going to use this. We're doing substitution. So you're plugging what either x or y equals into an equation, except this time instead of it being a number, it's going to be an equation. Okay, so let's take a look at these two equations down here. So I want to solve by substitution. Before I do that, though, I do not want to use this equation here as fractions, so I'm going to get rid of the fractions first. Okay, so let's just take this first equation. And let's get rid of the fractions. So that means I'm going to multiply each term by 5. Okay, so we're going to do that. We're going to get these 5s to eliminate, so it's going to give us x. Y times 5 is going to give us a 5y. These 5s will eliminate, and that'll give me a negative 27. Okay, so now I'm dealing with these two equations. I have x plus 5y equals negative 27, so that's my first equation. Then my other equation is negative x plus 3y equals negative 29. Okay, so you see up here it says solve, substitute into other, solve, substitute. So that is what we're doing. So when we say solve, that means isolate variable in one of your equations. So look for a single variable, so either an x or a y by itself with no number or no minus sign or anything like that in front of it. So if I look at these, I look at my first equation, I have x plus 5y equals negative 27. This x is by itself. So what I'm going to do here is I'm going to subtract the 5y, and I'm going to get x by itself. So I get x equals negative 5y minus 27. All right, so then I'm going to take what x equals, and I'm going to plug it into the other equation for x. So x equals negative 5y minus 27. So that's going to go into this other equation right there. Okay, so this is negative, and then I get my x, which is, and I'm going to change a color for emphasis here, negative 5y minus 27, and then I bring the rest of the equation down. Plus 3y equals negative 29. Okay, so you get that plugged in. Now you're going to work this out. Okay, so if I work this whole thing out, I'm going to get, this is a negative 1. So I'm going to distribute this. So negative 1 times negative 5y will give me a positive 5y. Negative 1 times negative 27 will give me positive 27. Bring down the plus 3y. Bring down the negative 29. Let's combine these terms here. So I have 5y plus 3y. That'll give me an 8y. Then I'll take the 27 and I'm going to subtract it. And I believe that gives me a negative 56. Let me check. Yeah, negative 56. So I get 8y equals negative 56. And then I'm going to divide by 8. So I'm going to get y equals negative 7. All right, so I get my y. I'm not done yet, though, because remember, it is a pair of solutions. So you have an x and a y. So if I have y equals negative 7, then go back to, you can either go back to the original problem with the fractions, which no fun. Let's go back right here where it says x equals negative 5y minus 27. Plug the y in now. X equals negative 5 times negative 7 minus 27. So negative 5 times negative 7 is positive 35. 35 minus 27 will give me 8. So I get x equals 8. So x equals 8, y equals negative 7. So we write the answer like this. So you come back up here. There is one solution. The solution is 8, negative 7. Check it. Okay, so you have 8 for the x and negative 7 for the y. That first one, a little annoying, but let's see. 8 over 5 plus negative 7 gives me negative 5.4. Is that what negative 27 over 5 is? Yes. And then negative x, so negative 8 plus 3y, so 3 times negative 7 gives me negative 29. So it works in both equations. So you always want to make sure that you plug that back in. Okay, so let's try another one like this. Okay, so we have example 4. I always like to take them when they're stacked like that if I'm going to do substitution and write them separately. So I'm going to write my first one right here. And then I'm going to go with the second one over here. So here I really have a couple variables I could pick because I'm just looking for an x or a y by itself. So since we did x last time, did we do x last time? Yeah, let's do y this time. So let's solve for y in this equation here, since y is by itself. So I'm going to take this equation, subtract the x. I'm going to get y equals, that's going to be just negative x minus 4. All right, so that's the y. So then I'm going to take that and I'm going to plug it into this equation right there for y. Okay, so this equation goes like this. X minus 2, then my y, which is now going to be negative x minus 4, equals 14. Okay, so my y has changed to that negative x minus 4. And then I'm going to work that out. So I have x. I'm going to distribute a negative 2. So negative 2 times negative x will give me a positive 2x. Negative 2 times negative 4 will give me a positive 8 equals 14. Then I'll combine my like terms, x plus 2x. That'll give me a 3x. Let's go ahead and subtract this 8 over here. 14 minus 8 is 6. So I have 3x equals 6. I need just a little more room here. And then we'll divide by 3. So we'll get an x value of 2. So we get what x equals 2. And then we can go back to either one of these and plug it back in. So it doesn't really matter here. Probably the first one's easier. X plus y equals negative 4. So 2 plus y equals negative 4. So if I subtract 2, that should be a negative 6 for y. So my answer, 2, negative 6. So x first, then y. And then just check that. So 2 plus negative 6 is negative 4. Works in the first equation. Then 2 minus 2 times negative 6. So negative 2 times negative 6 is positive 12. So 2 plus 12 is 14. Works in the second equation as well. Okay, any questions on that method? All right. So now let's look at elimination method. Elimination method, it is just like it sounds. You are going to need elimination method when you do college algebra and pre-calc. So that is the one that will carry over into those subsequent classes because you're going to get 3 equations with x, y, and z. Elimination is going to be the method, the easiest method to solving. Okay, so this one is probably the most important one. Okay, so you want the equations in standard form. If they're not in standard form, you get them there. So that's x and y on the same side. Then what you want to do is you want to look at the equations, the coefficients, so the numbers in front of the letters, okay? You want them to be the same number with opposite signs, okay? Because we know that negative 5 and positive 5 are going to eliminate. That's what you want to end up doing. If they're not, you just multiply one of the equations by the number to get it that way. Sometimes you have to multiply both. So let's say you had like 2, and 5, and you needed to make those the same number. Well, then you would multiply this by 5 and this by 2. They'd both be 10, but you need one of them to be negative. So you would just make one of them negative. You'd have negative 10, positive 10, then you could eliminate them. Okay, so you're just going to be using multiplication to get them to eliminate. Then you're going to add the equations together, solve, substitute. Okay, so let's go ahead and we can really do the x's or the y's. Typically, the easier thing to do, if one of them's positive and one of them's negative, use that one. So let's say we want to eliminate the y's. Here we have a 1, here we have a negative 3. So we need to multiply this equation by what? 3. We got to multiply by 3. So you do the whole thing. 3 times 5, 15. 3 times y will give us plus 3y. 3 times 13, 39. And then the second equation, since we don't need to multiply that, we just carry this over. And you line them up on top of each other like that. Then you add them. So 15x plus 1x is 16x. 3y minus 3y, gone. 39 plus 9 is 48. And you just get this equation here. 16x equals 48. And then we solve. So we divide both sides by 16. And 48 divided by 16 is what? 3. So you get your x. Once you get your x, you do the same thing you did with substitution. Go back to one of the original problems, plug it in. So let's say I go back to the first problem, 5x plus y equals 13. And I say 5 times 3 plus y equals 13. Well, 5 times 3 is 15 plus y equals 13. That's going to give me a y value of negative 2. So I get my solution there, 3, negative 2. And then we want to check it. So we say 5 times 3 plus negative 2 equals 13. It works in the first equation. Then 5 minus 3 times negative 2 does not give us 9 because I put 5 and not 3. So the x value is 3. So 3 minus 3 times negative 2. That will give us 9. So it works in both equations. Okay, so this next one's kind of messy. What do we want to do first before we do the elimination method? Yeah, let's get rid of the fractions. So first one, I'm going to multiply by 6. Okay, so I'm going to multiply each term here by 6. So that's going to give me, these 6's will eliminate. That'll give me a 5x. 3 goes into 6 2 times. 2 times 2 is 4, so that's a 4y. 12 times 6 is 72. Okay, second equation. What's the common denominator here? What's this common denominator? 24. Okay, these 24s are going to cancel. That's going to give me just x. 6 goes into 24 4 times. So that's going to be minus 20y. And then negative 2 times 24 is going to give me a negative 48. Okay, so the fractions are gone. So now we want to eliminate these. So we can eliminate either the x's or the y's. Which one do you want to do? All right, I'll pick. Let's do the x's since we did the y's last time. All right, so I need these 5's to be the same number, which means I need to multiply the second equation by what? Good, negative 5, because I want them to end up eliminated. All right, so that means this is going to give me negative 5x, negative 5, well, there we go. All right, negative 5 times negative 20, going to give me a positive 100 y, and negative 5 times negative 48, positive 240. Okay, we're going to bring this equation over. And now we're going to add them. So 5x minus 5x is going to eliminate. 4y plus 100y is 104y. 72 plus 240. 312. And then we will divide both sides by 104. And we get 3. Okay, so we got our y value. We can go back to the original equations, which probably no fun because they have fractions. So we can go back to these guys here. Let's plug the y value in. So let's say we use x minus 20y equals negative 48. X minus 20 times 3 equals negative 48. So x minus 60. And I add 60. That's going to give me an x value, 12. So I'm going to get the solution 12, 3. I'm going to check it. So we say 5 times 12 plus 4 times 3 equals 72. And then 5 minus 20 times 3 equals, I keep doing 5. 12 minus 20 times 3 equals negative 48. So it works in both equations. Okay, so let's look at some examples of when you might have no solution or infinitely many solutions. Okay, so I think this is an example of no solution. Yeah. Okay, so we go to graph this. We'll do it graphically, and we'll do this one with substitution. Or actually, let's do this one with elimination, but we'll do graphing first. So you have 3x minus y equals 8. We want to get y by itself, so we're going to subtract a 3x. We're going to get negative y equals negative 3x plus 8. And then we're going to get rid of this negative, so we're going to divide everything by negative 1, which is going to give us y equals positive 3x minus 8. So we're going to go graph this. Let's see, we're going to find negative 8 on the y-axis for our y-intercept. That's going to be right here. And then our slope is 3, positive 3. So I'm going to go up 3 over 1. All right, so we start forming the line, then we can draw the line. And there we go. Okay, so we have our first line graphed. Okay, then we're going to take a look at our second equation, 12x minus 4y equals 8. Okay, we want to get this y by itself, so we'll subtract the 12x. That's going to give us a negative 4y equals negative 12x plus 8. And then we're going to divide everything by negative 4. And that will give us y equals negative 12 divided by negative 4, positive 3x, and then 8 divided by negative 4, negative 2. Okay, so notice there they have the same slope, so they're going to be parallel. Can graph this. Here's negative 2, go up 3 over 1, and you start forming that line. And you're going to see that you have 2 parallel lines. Okay, so that would be an example of no solution. We're solving graphically. It's fairly obvious. They're not going to intersect. Let's say, though, I'm doing this problem and I want to solve it algebraically. Okay, so I have my 2 solutions or problems here, and I'm going to do this using elimination. So I'm going to take my first equation and I'm going to multiply by negative 4 so I can eliminate the x's. Okay, well that's going to give me a new equation of negative 12x. Negative 4 times negative y will give me a positive 4y. And negative 4 times 8 will give me negative 32. And then I bring my bottom equation over. And I add. So I succeed in eliminating the x's. But what ends up happening are the y's are also going to eliminate, because 4 minus 4 will also be 0. So I get 0 on this side, and I get negative 32 plus 8 on this side. So I get 0 equals negative 24, which is false. 0 does not equal negative 24. That's a false statement. So there you get your no solution again. You do not have to unless the problem says to graph it and it has the graphs on there. On the test, I think there's one question where I ask you to graph, the other one just says solve algebraically, so using either method you want. Okay, so let's look at now an example of where we have infinitely many solutions. Okay, so let's graph these lines. So I have the first line, x plus y equals 1. Okay, I could graph that in standard form just with your x and y intercept if you wanted, but if I solve for y, I get y equals negative x plus 1. So I have a y-intercept of positive 1 And I'm going to go down 1 over 1. So my graph's going to start to look like that. Get my line through there. Okay, so I have my line. Then my second equation, I have 2x minus 2y equals 2. Okay, so we want to get y by itself, so we're going to subtract 2x. We're going to get negative 2y equals negative 2x plus 2. Then divide everything by negative 2. And that's going to give us y equals negative 2 divided by negative 2. That'll just be 1x. Or no. That's right. Positive x. And that will be 2 divided by negative 2 minus 1. Oh, these aren't infinitely many solutions. I got to fix this. This is a plus sign. Just write this down here. These would actually intersect. But I want to show you infinitely many solutions. So just fix that. It should be a plus sign right there. So that means that this is just a positive 2. So we're dividing by positive 2 here. Which means this is going to end up being a negative x plus 1. If you go to graph it, it's the same exact line. Okay, so plus 1, and then down 1 over 1, you start getting the same line. Okay, so that's infinitely many solutions when they graph to form the same line. Now, we did elimination the last one, so let's do substitution for this one. So let's say we have this problem, and we want to solve it using substitution. Okay, so you have x plus y equals 1, 2x plus 2y equals 2. So let's say we do the substitution here, and you get y equals negative x plus 1. And then you say, okay, well, I'm going to take that, and I'm going to plug it into the second equation for the y value. That's a bad line. There we go. Okay. We're going to go right there for the y value. So that's going to end up being 2x plus 2, and my y value, negative x plus 1, equals 2. And then we work that out. So this is 2x. This is going to be 2 times negative x, so negative 2x. 2 times 1, 2, equals 2. Well, what ends up happening here is 2x minus 2x is 0, and you get the statement 2 equals 2. Well, that's true. 2 does equal 2, but there's nothing to solve for. There's no x or y left. So the variables have eliminated. You get a true statement. That gives you the infinitely many solutions. So that's what would happen algebraically in this case. And then a real world example here. Okay, you have a word problem. Let's read it. In general, as the unit price of a commodity increases, the demand for that commodity increases. Supply and demand, Econ 101. Also, as a commodity's unit price increases, the manufacturer normally increases the supply. The point where the supply is equal to the demand, that's what you want, where they're equal to each other, that is called the equilibrium point. And then this says find the number of DVDs and the price per DVD when supply equals demand. So this case here, it just wants to know where do these two intersect. And it's graphed for you. So you're just looking for that point. So what is the x value of this point? looks like it is a 6. And what is the y value? 23. That's all you're doing there. Okay, so we're not solving a problem like this yet. That's in Module 10. We will do that in Module 10. But you're just looking at the graph, finding that equilibrium point. What is the x and y value there? It's just telling you what this is, supply and demand, which is something that can be used in real life.